Hello. Okay. Is everybody here? Okay, good. I'm just gonna add hello everybody. Just going to start. I'm just wondering how you can put comments on here. No, I don't know how to put comments. Like the chat feature. Okay, I just have to keep flipping back and forth. Okay, so first of all, we are going to start by looking at SFML chess. It's not complete yet. I'm still working on it. I've been working on it recently. And this is just chess game. Like, I think it's very different to how other people would have implemented by just over. Okay. I just need to find. What's this scene? No. Can everybody see me on my sources? Just going to. Oh, you got a chat? It says one chat right. Is there anybody here? I'm just trying to get things set up for now. Is there any? No viewers at the minute. Just waiting for a viewer to come and then I'll start the stream. Okay. Let me just see. No chat right now with viewers, sadly. Video tutorial. Okay. Here we go. Now I'm back here. So this should be working. Okay, fine. Now we can resume. Okay, so this is SFML chess. It is a application programmed using SFML and using C++, C++20 standard. We can see this. We go into properties. Have a look here. We can see, C++. We can go to all options, or we can just go to language. You can see, sorry, C++ standard. Okay, so now let's have a look at the code. Actually, first of all, let's just run it. Let's see what it does. Okay, so just building. It's got a lot of warnings here, 83, but like I thought first I'll just build the project, then I'll go back and refactor on what needs to be done. Okay, so I'm running the project now. Okay, so we've got these. They're terribly drawn sprites, but because I'm not a good artist and like I couldn't find a good 20 by 20 pixel wide one, and I chose to keep it small, just like so you could have it and it automatically resizes. So you can have it like, oops, oops, what am I doing? Okay, so you can easily move pieces. So you click on a piece and then you click somewhere else. But then, so if you click here, then click on a piece, that means this piece is still selected. But what I need to implement now is that, like, the box around it goes like yellow or something. That's what normally happens, or it goes a bit darker. Because I've just selected that pawn there to go to there, which I didn't actually want to. But one of the problems now is that, like, these pawns, that they can move anywhere, because I actually haven't implemented their own class, and the white pawn wasn't actually taken. It's actually still just under the black pawn, but the black pawn just moved onto it, and it happens. And you can delete this by pressing Z. Deletes them both because they're both in the same box. Actually, no, they don't, because pawns. Sorry, what am I talking about? Okay, so you just need to wait. I'll run it again. Fine. Okay, I'll just have a quick check up on the chat. Okay, still nobody here, but you can watch it, or I can watch it when I'm older and see my standard. Okay, let's minimize this. Get back. Okay, so this is the chess, and then, so what we can do, Q is to make a white pawn, A is to make a black pawn, then W is to make a white castle, and then S is to make a black castle, like that. So then it goes all the way across to Y and H, and like what you can make with them. And to delete ones, you just press Z. But my keyboard is playing up. Oh, I know. Well, first of all, we're gonna have to program it so that because I made this extra class, which is I see. It was working the other day though, I thought. Anyway, I made like extra classes, additional pieces, because I made this board, and like, because if you have more than the two you're supposed to, so that's why there's a problem, because of there would be 3 of each castles, which wouldn't make sense, so that's why it's playing up. But yeah, I could add some more handling. So you can just like delete the whole board here, and then you can literally just make them again. Oops, wrong one. So you just press. So you can like set up a board how you want, and so it would be S, D, F. Oh, I keep messing it up. Sorry. No, it is working. Delete is working on. Yeah, this castle always plays up for some reason. Anyway, so that's a gist. We'll have a quick look at the code and see if anything can happen with that. Okay, nobody here. Wait, I'll just try and make it so that it's only display capture. Okay. YouTube is not responding. Yes. No. Okay, first of all, we're going to delete this. Remove. Okay. Let's just get back onto track. Okay, so let's have a look at the code. So first of all, I was trying to make it as a like static project, so you don't need anything more to add to it. Like you could just ship it as a .exe file. But like I still need to embed all of the like sprite files into it, like black pawn.png, white pawn.png. Okay, so first of all, so I've made 2 different things, because I've made one map for pawn pieces. Like originally I was doing it for all of the pieces, but then I think like you see all of this repetition here, that's all for each of the pieces, and I thought that would be so tedious just doing like times 2 for all of the other pieces, pawns rather. So I just made a separate one, then made a really quite simple function that we just make the pawn, and then we initialize it with the texture, and then we just print these out using this special like method. Like this method is like, so you find the index of where the pawn is in the vector. It's a vector of vectors, and then so you find where it is. I think it's a vector of vectors, isn't it? No, it's not. It's just one big vector. Okay, so you find where it is, and then you divide it by 8, and then because that's how many are in a row, and then you can work it out from there. So that's for the pawns. It's really simple to help with them, but that's the reason they can go anywhere, which is so I might need to just. So what I could do, I suppose. But then you also got the issue of when it gets to the end, you have to. When it gets to the end of the like opposite sides, you've got to turn it into like a queen or horse rather. So, but an interesting thing that I found out is like why doesn't it automatically go to queen? Because like they offer you pieces like a rook and a castle. Like, why do they do that? Why don't they just give you a queen? Well, this is because this can cause stalemate. So you don't want it causing stalemate, because so instead of getting queen, you just get like a bishop or something. So yeah, that's one of the reasons. But what I think I could do is I could just limit. Okay, I'll open up Paint. So what I'm currently thinking is, so we have the pawn. So we've got a box here. Now we've got another box here, and here, and here. I know it's terrible drawing, but this is the pawn on the X. So it can move forwards. If there's like a there's a piece here, they can move like that, and they can move like that. But they can't. They can also move like one step over here in this block. I could just limit the moves to, well, because they can move to this block because on their first move they can move 2 moves. So I could limit the pawn going to the diagonally to the top left or top right of the like respective box around it, if you will, and then it can move to the top middle box, and it can also move like one above the top middle. So I can limit it to that, because at the moment the pawn can literally go anywhere. So say it was all the way up here, it could go all the way to a box here, because I haven't put anything in place. All I'm doing is I start off just putting them here, and then when a pawn's clicked on, and I just handle it differently to all of the other pieces. So yeah, because like it's 16 pawns, and I don't want to be managing. Okay, past these. Okay, now we are on to all of these. So I made a class for each. We've got bishop, dot board. So, and to be honest, I think I like the way I've done it, but it may be a bit too verbose, to be perfectly honest. Okay, so the constructor we have of bishop takes the file name of where to get the texture. Then we have the chessboard pos. This is a special type of position that we just times by 25 pixels, so that so we have a method in chessboard pos. So I can show you now. Chessboard pos. Okay, so we have struct chessboard pos. Here we go. So we have default constructor, and we got this constructor taking x coordinate and y coordinate. So first of all, we can have auto 2 pixel position. This 2 pixel position just times it by 25, and this just converts it to, just uses this and turns it in, instead of a vector 2u to a vector 2f, because that's what most of the functions accept with XML. but there was some functions that did actually accept vector2f instead. So that's why that was 2u, because I was using this at the time. I actually made this whilst I was in Aberdeen. Okay, now we have this strong ordering C++20 spaceship operator in order to give easy comparison. We just make it constant experience header to default, and we use the include compare. Okay, and now I'll show you the definition of this. Just wall boss. So you can see we just times it by 25. Then we also use this. This was such a bad way of doing it, but anyway, we cast it to float. I should have just, you know what? I'll just times it because hopefully we don't break any code. This shouldn't break any code. That, I think it's just a bit verbose. We'll run it and see if everything works, and then I'll just commit it to make sure that we get on with things. Yeah, so we're just running. So if anyone does know, by the way, if you're watching this after, if you do know how to because I've looked it up online, but I couldn't find a good answer that I could refer to. How you embed a sprite file into a .exe file? Because I do not know much about .exe files. Yeah, well, it's just as planned because it was the same, but I don't see the point in creating this whole function. Then yeah. Because we already got these variables and we didn't say that. Yeah, it would probably be in RTTI? No. Runtime. No, not RTTI. It's the function returned when you return from a function. When you call a function, something's returned. I think RTTO something. No, I can't remember. But when you return from a function, when you call a function, something's returned. This gets optimized by the compiler and just is made into that value, like this. So it would just basically be this, I think. And I was having to call it twice, which is the problem. Anyway, I'll just commit this quickly. Change for both way of doing to vector to f. Now just copy this. Okay. Good commit messages always help, rather than just saying underscore. I do that sometimes when it's pretty useless commit. Well, no commit I would say is useless, but it's just so obvious. For this one, you may think it's changing behavior if you don't read the code carefully enough and you just hover over and your IDE just gives you this. Anyway, I don't know. Okay, back to where we were. Okay, go to bishop.cpp. Okay, so we take in the chessboard pass and we have the associated number. So this associated number we actually find in main CPP. So if we had a black knight, for instance, black castle, sorry, this would be 1. So .assoc num, associated number would be 1. And we can see, for bishop then, depending if it's what color of bishop it is, it would either be 3 or 19, or you have the other side, 28 or 22. So yeah, a lot of combinations. So that's why we pass it in, because there's 4 different combinations. And I suppose you could do it with passing in, if you had a white object, black object, and passed in left or right. But then yeah, that would just get confusing. That's why I just made it this way. Now we have the draw function. We just take in render window, and then we check that if this piece hasn't been taken, we draw it. Next, get all positions allowed to move. This is the bit this is the reason I chose to put these in classes. So because we can use abstraction to reuse these. Reusable code is always good. Okay, I'll show you that with the queen. The queen class. Okay, so first of all, we got a vector of chessboard positions. Like, these are the positions on the board on the vector. So it's easier to like differentiate. No, easier to go. Like, so it's easy that you have the vector and the actual output, where it is on the screen with chessboard pos. If we just had a stood pair or SF vector to F, I don't think it'd be easy because we're using it in a vector form. Then we have to transpose it like 25 pixels in large. It's not a good explanation, but I hope you understand. Okay, so we just have our x and y variables, and we set those to the x and y of position. And bear in mind, position you can find here where it starts off, and it's also like passed in the constructor. So what we have here is we check if the x is greater than 0 and x is less than 7. Y is the same for y. If we do, we increment them both and push back the because we need this to be, we increment them both because we need them to be diagonal. So if you increment the x variable and you increment the y variable, you get the diagonal of that first x and y. So if you say you had a plus plus operator on a stood pair, and then that would increment and say both are integers, a specialization of stood pair of int. So you just increment both of them, and same for decrement. So yeah, so we check this because we check so it's not out of bounds, because you could keep going on for infinity. So yeah, we only do whatever's in the board, and because it's I know it's 8, but yeah, indexing is 0. Okay, so and then we also do the same for the negative, but we shouldn't actually check where is it, if it's greater than 0, because we're going up anyway. So we could take those out, but it's just easier to reuse. Then we just push back these, and yeah, just the minus. Decrement both of them. You could use just minus, but I quite like just the minus equals and plus equals. And then we have the same for the other way. So there's 4 directions in which it can go. Okay. So now we have move to. So this we have all positions. So we get all the positions allowed to move to using this function that we just went through here. Notice I'm using constant except on almost all of them except for these, because window.draw can throw exceptions. My tongue's getting all twisted. And then it's not const because it's render. Well, it's render, but I don't want to get warnings. I can't remember, but for this one we're changing state, so it's not const. Okay, so now we have all positions. Notice it's a vector of chessboard pos. So in order to get to the actual position, we need to dot the dot transpose function that times it by 25 pixels. So we get all the positions allowed to move to. And